Now, copper occurs in combined states as sulfides, oxides, and carbonates. Copper pyrites and copper glands are the sulfide ores. Cuprite is the oxide ore, while malachite and azurite are its carbonate ores. Copper is mostly extracted from copper pyrites. The ore is first crushed into a fine powder and then concentrated by froth flotation. The concentrated ore containing iron as an impurity is roasted in a reverberatory furnace in limited air supply to obtain copper 1 sulfide and iron 2 oxide. Silica is also added in the mixture and reacts with iron 2 oxide to form iron 3 silicate, which separates out as slag. Copper is produced in the form of copper mud, which contains copper sulfide and iron sulfide. The mud is then introduced into a converter provided with a lining of silica. Blast of sand and hot air is blown into it. During this process, the remaining iron is removed in the form of slag, while copper sulfide is reduced to metallic copper. The metallic copper melts and sinks to the bottom of the converter, from where it is poured out into molds. When it cools down, sulfur 4 oxide gas escapes. Consequently, the copper obtained has a blister appearance and is therefore called blister copper. It contains 98% copper and is refined through electrolysis. Here, the impure copper is made the anode, while a thin piece of pure copper strip is made the cathode. An acidified solution of copper 2 sulfate is taken as the electrolyte. When current flows, copper atoms from the impure copper anode lose electrons to become copper ions and enter the electrolyte. They move towards the cathode, where they are reduced and deposited as pure copper metal. The more electropositive impurities like iron, nickel, and zinc are left in the electrolyte as their sulfates. The less electropositive impurities like gold, silver, and antimony settle at the bottom of the anode as anode mud. Precious metals like gold and silver can be recovered from the anode mud.